Unit 6, Chapter 24, Paired t-test and interval. And I also have an example of before versus after exercise program pulse rate. Okay, first of all, let's look at the paired t-test. So first of all, a paired t-test is exactly that. It's pairs of data that is not independent, but they're dependent on each other. They're independent. They're not independently chosen, and you have to make sure the key on seeing if something's a paired t is to see how the samples are chosen, or of the data. If you have sample A and sample B, the question is, are these two separate samples, or are they have the same subject, subject 1, subject 2, and so forth and so on. If I'm using the same subject, they'd be paired. If I'm just doing sample A and sample B and I'm asking to compare them, that would be a 2 sample. So remember, if I'm paired together, that I've got subject 1, subject 2, subject 3, or something like that, then I'm going to be comparing them if it's sharing the subject. All right, how to do a paired t-test. So if you notice here, if I ask for before data and then I ask for after data, the reason I had it crossed out, which I'll cross it out again, is the before data and the after data is irrelevant. What is relevant is the difference of the before minus after. So that was just before minus after. And so if I had, I'll go ahead and do it. If I had a 3 and a 2, this would be 1. If I had a 2 and a 5, this would be -3, and so forth and so on. And then, so what you're doing is that step 1, you're finding the differences of your data. And then step 2, you're finding the mean of the differences and the standard deviation of the differences. Of course, you can do this with a calculator, one variable statistics, or it's given to you and you use your t-test. All right, so when we do phantoms, we're going to, first of all, define the parameter. The parameter for this one is mu d, is the true mean differences between A and B. Now be careful, I have seen people do this, mu d equals mu1 minus mu2, and that is not true. Mu1 minus mu2, that is population 1 minus population 2. And what this is the difference of the means. You see? So do not put that on your paper because it is not true. This is absolutely not true. This is not true. This is the difference of the means. What you did over here is you found the mean of your differences. We found the differences first, then the mean, and that's what the difference is. And you would do this. You would say the mean of the difference thing, you would say like this. B minus A or A minus B. That's how you would put it. You would not put it like this here. All right, so with your hypothesis is HO is mu D. Usually we have is equal to 0, unless otherwise notated. Every single one that you're going to have in my class. And most of the AP stats will be mu D equals 0. That means no difference. There's no difference between before or after. There's no effect. And then the HAV, of course, is going to be less than, greater than, or not equal to. And all delta means just means change. Okay, assumptions and conditions. Your same thing that we've been doing for a sample, a mean. We're going to say random sample. Are they random sample using paired data? Well, it's paired data, so it's not independent. So I do this one with RILT. I have check my random sample. And I say it's not independent. They are pairs. You got to state that they're pairs. Now, obviously, each pair is independent from the next pair, but the pair itself is not independent. Large sample size. The large sample size is the same way we've been doing it, where if it's small, you have to show no outliers, unimodal symmetric. If it's medium, you have to show unimodal symmetric. So if there are outliers in a medium-sized sample, then you're okay. And if it's large, you're not necessary to check conditions because of the CLT. CLT is central limit theorem. Central limit theorem says if you have a large enough sample, your sampling distribution is approximately normal. I do accept over 30, so you can just use 30. You don't have to go all the way to 40. All right, naming the procedure. This is a paired t-test. We're going to use the procedures in our calculator using a one sample t-test because it has one list that we're doing, which is just this list. It's just that one list, because I will not be using this list at all, or this list. I will only be using this list here. So we're going to be using one sample t procedures, but it's not a one sample t-test. It is a paired t-test. And you have to have the degrees of freedom. The degrees of freedom is n minus 1. So don't forget to put the degrees of freedom of n minus 1. To find your test statistic, you have your parameter minus statistic divided by square root of s divided by square root of n. If you look at your one sample t-test in blue, it looks very similar to your paired t-test in pink. The difference is that this, the mu d is usually 0. So that brings me up to this equation here, which is just d bar, or x bar diff over s over square root of n. All right, when you draw it, this is all we label. We label it as t n minus 1. When it's a t curve, I label my p-value. And of course, same thing else is everything else is the same. If p is low, reject ho. We do not have, if p is low, reject ho. We do have enough evidence to reject ho and to state ha. If p is greater than alpha, we fail to reject ho. We do not have enough evidence. If you see here, this is a great definition of p-value. The p-value is just the percentage on my curve. This is the p-value, and that's the percentage of times that we observed my t that we observed, that's my observation, the percentage of time we observed by chance in this size sample. All right, so everything else with phantoms is the same, so let's go ahead and panic is absolutely the same what you've been doing. The interval, of course, is just going to be d bar plus or minus n minus 1. Okay, so we did this one in class, our speed dating one, and here's a class example we're going to just go through real quick. All right, so this is asking, is there evidence that the kind of exercise can reduce resting pulse rates? If you hadn't read this one, go ahead and put the video on pause and read through it. So this can reduce resting pulse rate. Is there evidence? That indicates I have a hypothesis test. When it says how much, that indicates it's a confidence interval. And usually it'll tell you what my alpha is here. If it doesn't, you can use any reasonable alpha you want to. And this one here on the confidence interval, it'll tell you use a 90% confidence or 95% or whatever you want to use. All right, let's go ahead and do this hypothesis test. The first step, what I did is I put all this in my calculator. And I put before and after, and then I just found the difference. So you can put this in your calculator really fancy, but you don't need those. This is the list that I need. And so I have mu d is the true mean difference of resting pulse rates in men before minus after. A physical fitness of 3 times a week of 20 minutes a time is implemented. So my ho is mu d equals 0. My ha is mu d is greater than 0. My conditions are random sample, men who are volunteers, so conclusions can only be to this group of men because they are volunteers. If you look up there, it says that. Independent, they are not independent, they are paired. The pairs are the subjects. You see, Alan has his pair is before Alan's pulse rate and after Alan's pulse rate. And Alan has to be paired with Alan. It can't be with anybody else. Large sample size, I look here and I say, okay, n is less than 30. It's actually equal to 10. So I have to go ahead and graph it on my histogram. If you're not sure how to do this, check out my videos of how to graph and run a paired t-test. And then approximately symmetric, no outliers, and unimodal. I just state that. I make sure because it's a small sample. 10% rule, I see that all men in the exercise program are less than is greater than the 10% of the sample that we have done. So the conditions are met, paired t-test, degrees of freedom, 10 minus 1 equals 9, and don't forget to put your t equals 2.8. You want to see where that comes from? Of course you do. Well, here, what I did is on my calculator, I found the 2.8, which is my mu d, and then I found 2.53, which is my standard deviation. But let's go ahead and show you. I'll show you how to find it in the calculator. All right. Let me just put this in. Okay, so for here, this is, I'm just going to call it DIFF example. And I'm just going to put the data in, 0. This is just the data that I subtracted, the before minus after. 1, 4, 8, 3, 2, -1, and 3. And that's my data. And so I'm going to go run a test. So I'm going to go menu, stats, test, and we're running a t-test. Notice there's nothing that says paired, but we're running a t-test because I only have one list of data. But this is a paired t-test. So I have data, and my mu 0 is, my mu naught, my hose mu is 0, meaning I have no difference. My list is called diff exam. Okay, and then my alternative hypothesis, we look back here and remember it was greater than 0 because I'm saying that I have a reduction in rate, which means my before minus after, it gets smaller afterwards. So if the before was 100 and the after was 80, that's going to be 20, and that is greater than 0. And so that's a reduction. So that's why it's going to be greater than. And I'm going to go ahead and shade it just for purposes. Okay, so I have my p-value, I have my shade, I have all of my data here. And so if you notice, I'm just going to take the t, which is 3.5. I'm going to take the, which is right here. My p-value is 0.03. And my degrees of freedom is 9. X bar, which is the average of all of those numbers I put in, is 2.8. My standard deviation is 2.5, and n is 10. So, and if you notice, let me show you this, kind of cool. For my t, look. My t equals 2.8 over 2.5982 over square root of 10. So those are the numbers that I'll be using here in a second. Okay, and that's where this comes from here, 2.8, just what I just said. And 3.5 I already had on there, and I shade it, and I say, okay, my p-value is 0.034, so since the p-value is so low, less than alpha, and I used alpha, my alpha actually I used at 0.025. I just chose a 0.025 because I'm doing a 95% confidence interval, so that lines up with it. So I'm rejecting the HOPE because there's no difference of resting pulse rate after the exercise. And we have convincing evidence. We have a lot of convincing evidence because my p-value is really tiny. All right, for a paired t-test, what you would do is, of course, you would have to find phantoms, and you would do, for phantoms, you would do the p and the a, which we already did. Name the interval. It's a paired t-test with degrees of freedom of 10 minus 1 is 9. And then this is just x bar is 2.8 plus or minus t star, which is degrees of freedom, 95%. And I'll get to that in just 1 second, times the standard error, which is 2.53 divided by square root of 10. Okay, so if I find this here, I have the degrees of freedom is 95% confidence interval. So to a 95% confidence interval, remember that's my center, 95%. And I got a tail here of 2.5%. And this is the value here that I'm looking for on my t-curve right here. But my calculator has a problem because it starts right at the beginning. Ooh, that's gigantic. It starts right here at the beginning. And since it starts at the beginning, if I did 95%, it would be a little bit shy, like, and put it right here. So I need to add that extra 2.5%. So I'm going to go to inverse t on my calculator because I'm looking for t star. So I'm going to go to menu, stat, distribution, inverse, not inverse norm, I apologize. I got to go all back to do it. Inverse t. And that is 0.975 because I'm looking for a 95%, and that's my extra tail. And degrees of freedom is 9, and that value is 2.26. So that's where I got the 2.26 from. In doing the paired t interval, I would do the paired t interval. Let's go ahead and do that here. Menu, stat, confidence intervals, and I'm going to do paired t interval, which means that's just a t interval, And I have data still because I still have my data that I called diff example. And I'm trying to find a 95% confidence interval, so I just do that. And there we go. There's all the information I need. Okay, and all the information is there, and it gives me my lower bound and upper bound. And so we are 95% confident that the 6 weeks of exercise in this program reduces the heart rate approximately 0.99 to 4.61 beats per minute. And if you notice, 0 is not in the interval, 0 is over here, which means it is new information. This is something different, and that would also be a reject, which is what we got in our test. All right, that should be about it as far as your test here. We've gone through the paired t-test. We found the calculator using the t-star, talked about the t-test and the paired interval, and talked about an example. So hopefully you do well, and hopefully the sound works this time.